Hey. One thing I want you to do while going over this PowerPoint is make a concept map. Now, for those of you who don't know what a concept map is, typically what happens is you have some kind of central theme which we draw or write in the middle. And branching off from that central theme, we have many main ideas, and branching off from those main ideas, you have many sub-ideas. So in this case, in the center, we would have macromolecules. This PowerPoint's all about macromolecules. We'd write macromolecules in the middle. Branching off from that, because we're going to be talking about 4 different macromolecules in this section, we could just list those macromolecules here. So carbohydrates, proteins, nucleic acids, fatty acids, for example. Now branching off from, those main ideas or those macromolecules, we could have a bubble that says, I don't know, monomers. So what are the monomers of that macromolecule? What are the polymers? Another one would be polymers. What are some uses for that macromolecule? So here we have an example given for states of matter. States of matter is a central theme, and then branching off from that, you have all of the states of matter. You have gas, you have liquids, solid, plasma, and then branching off from that, you have different sub-themes, sub-ideas. All right, so I'm just going to actually start you guys off. I'm going to use carbohydrates as an example. So I'm actually just going to keep this on the side so I could use it as reference. And let's expand this. Okay. So central theme. What is the central theme here? Let's see. Macromolecules. Macromolecules. And branching off from macromolecules, we've got, oops. I'll just draw all 4 of the bubbles. This is definitely not going to be perfect, but neither does yours. Okay. So here we'll have proteins. Here we'll have nucleic acids. Here we'll have fatty acids or lipids. And then we'll have carbohydrates. Okay. I'm going to do carbohydrates as the example. So branching off from carbohydrates, what is one thing that we can list first? How about the monomers? What are those monomers? And actually, in parentheses, I'll put monosaccharides. And then, below this, instead of drawing little lines, we don't have to make it too complicated. I'll just make a little list underneath it, some bullets underneath it. So what are the monomers that I covered in the lecture, in the PowerPoint? I list glucose. I list fructose, both of which are 6-carbon sugars. And I also list ribose, which is actually a 5-carbon sugar, or pentose. I'll actually just go back here and list 6-carbon. Fructose is a 6-carbon. Cool. Now I'm sure the textbook includes a lot more. You can include those if you want. I'm just going to include what I have listed in the PowerPoint. So that's our monomers. What's another category? I mean, we could go pretty linearly. What are some dimers or disaccharides? Dimers, di meaning 2. Disaccharide, di meaning 2. Disaccharides. And that's just two linked together. Two of your monomers linked together. So what are some that I list in the lecture? I list sucrose. What is sucrose? I'll fill in that fun fact. Sucrose, which is going to be glucose plus fructose. And then we also have maltose. And that's going to be glucose plus glucose. Cool. Fulfills that category. Those are the two that I list in lecture. Just to kind of branch off a little bit here, what's going to be linking those together? When you make those disaccharides, what's linking those things together? So I'll make another category called types of linkages. I think that works. Types of linkages. What are the types of linkages? Well, we actually just list one. Glycosidic linkages. Okay. Now this is going to be a very important one. I need you to know the types of linkages for all the macromolecules. All right. What's another category? We could go with the polysaccharides now. I'll just draw a bubble up here. What are the types of polysaccharides that we have listed? Or actually, looks like I go over oligosaccharides, which consist of 3 to 20 monosaccharides. Can this fit? Yes. And so here I don't necessarily list any names, I just give characteristics, and that's fine. Let's give some characteristics. The main characteristic is that they're composed of 3 to 20 monosaccharides. And they're going to be used mainly as surface signals. Cellular surface signals that say, hey, I'm a friendly cell. Don't eat me. All right, so we got monomers, monosaccharides, disaccharides, oligosaccharides. Let's talk about the complex carbs. These are going to be the very large macromolecules. So we'll just put complex carbs or polysaccharides. Polysaccharides. So this is going to be things like your starch, your glycogen, and cellulose. Those are the three I cover in lecture. And what is starch? Let's add some detail here. So what is starch? That is going to be the way plants store sugar. So we'll just put in here plant storage. And then just to add even more detail. So that's going to be your plant storage. To add some more detail, it's water soluble. Meaning it dissolves in water. Glycogen. What is your glycogen? That's going to be animal storage. And what's some detail about that? It's going to be water insoluble. And same with your cellulose. That's going to be water insoluble too. And your cellulose, that's going to be typically used as plant cell walls or cell walls. I'll just put cell wall. Water insoluble. Cool. 1, 2, 3, 4. All right, so let's do like one more category. Now there might be more categories, especially depending on, you know, you're gonna have it's gonna be more nuanced for each category, for each macromolecule, like your lipids. You might not necessarily have monomers, but you're gonna have building blocks. You're not gonna have disaccharides under lipids, or you're not even gonna have dimers for that matter. So all of these are gonna be kind of nuanced. I'll let you guys figure out what kind of categories you want to use. This is mainly for you to use as a study tool. All right. So last part, we'll just say, what are the functions? What are the uses of your sugars or carbohydrates? We know that in carbohydrates, I mean, when we think of carbohydrates or we think of sugars, we think of energy probably. So we'll just say energy. And that energy is actually stored in carbon-carbon bonds within your sugars. It's used for cell surface signals. Yeah, we're going to be a little redundant here because I know I mentioned it up here. Cell surface signals. Also used as for your carbon skeletons. Okay, so this is what I have. You may have more. Hopefully you have more. But this is just an example to hopefully set you on the right track for making your own. All right.